We're going to look at Karnaugh maps in this video. In particular, we're going to look at an example of a Karnaugh map with three variables in it. So first up, what are Karnaugh maps? Well, you'll know by now from our classwork that the Karnaugh map is just a way of grouping together and simplifying the min terms in a truth table to get us to the simplest possible expression, which will give the results in that truth table. So we'll start with a truth table, and here we have a basic truth table with three Boolean variables, A, B and C, and a results column. So what we need to do is transfer all that information from the truth table across into a Karnaugh map, and then use the Karnaugh map to generate the simplest expression that will give the same results as that result column from those three variables. And we'll start by drawing our Karnaugh map. Now, in this particular case, we have three variables, so that there are 2 to the 3 or 8 possible min terms that we would need to use. So what we need to start with our Karnaugh map is a grid or a table with 8 slots in it, or 8 places. Then we put the variables around it. Starting at the top, we put the A variable on the top, and then divide the grid into two halves, one half representing not A and the other half representing A. Now, it doesn't matter which way around you put those, you just need to make sure that half of the grid is not A and the other half is A. Then we put our B variable down the left hand side, and once again we divide our grid, this time horizontally, so that the bottom half represents, in this case, not B, and the top represents B. And the third variable goes at the bottom. And once again, we divide the grid up into not C and C, but you'll notice we do it a little bit differently. The grid is still half not C and half C, but we've divided it up so that the outside columns are C and the central two columns are not C. Now that gives us a grid of 8 spaces, and each space represents a particular min term in our truth table. So let's have a look at that. And you can see there, if I put in the values for A, B and C, that the top left space, for instance, represents A0, B1 and C1. So that represents the min term not A and B and C, or 0, 1, 1. And so on with all the other spaces in our Karnaugh table or Karnaugh map. Now let's transfer our results from our truth table into our Karnaugh map. Now the first one there is not A, not B, not C. So we look at the not A half of the Karnaugh map, the not B half of the Karnaugh map, and the not C section of the Karnaugh map. And those three intersect at that point that you can see indicated by the red arrow. So we transfer the result 1 from our truth table to that particular box in our Karnaugh map. Going ahead and doing that with the rest of the results in the truth table, we end up with this. Now I haven't bothered to transfer the zeros across, the not values across, because we don't need those. Some people still like to put them in or mark them with a dot, just to ensure that no mistakes have been made, but I'll leave them out because we don't really need them. Now, first step in processing this Karnaugh map is to form groups of true values. Okay, so we need to group them, and these are the rules we use in grouping them. First of all, we group them in rectangles or rows, which is really just a thin rectangle. We also need to group them in powers of 2. So each group needs to include 2, 4, 8, or so on ones or trues. We also need to group them so they're in the largest group possible. Now, using those three basic rules, you can see that there is a group across the bottom. That row of ones across the bottom forms a nice group. It's as big as possible. It's 4 entries, and it's rectangular. So we select that one first. Now if we look at that, we'll see that those 4 true values, those 4 ones, represent not B. You'll also see that they cross over not A and A, and they also cross over not C and C. So what that really tells us is that that particular group doesn't matter the value of A and C is. It doesn't matter what the value of A and C is, they can be either. They're not important, so therefore they're not factors in describing that group. The only thing that is important about that group is that we have not B. So the first term in our expression for this truth table is not B. Now we need to keep grouping until we've got all the ones grouped somewhere, and there's one left. Now we could group it by itself, but that's not obeying the rule of making the groups as big as possible. What we really need to do is to group that one in a pair there, and you'll notice that our groups overlap. That doesn't matter, they're allowed to do that just as long as we have our big groups. Now looking at that particular one there, we have A is true, C is true, and B can be either 0 or 1 for that group. So B doesn't matter this time. So we have A and C is the expression that represents that little group on the right there with the two ones in it. So forming our expression, we take the not B and the A and C for the other group, and we just OR them together. So we find that the simplest expression representing the results in that truth table are not B or A and C. And that's how we can use a Karnaugh map to get a simple expression to represent the results in a truth table.